But I spoke to Brother Stone a couple of different times after it was over, and one of the things that he told me, he said, look, I'll share my PowerPoints with you. If you can use something in there, that's fine. And so a lot of the images, in fact, all but maybe one of the images in this PowerPoint tonight come from his presentation. I apologize, Bob, you've seen a lot of this already, but it's been almost 2 years, so maybe it won't be too repetitive for you. But some of this Bob has heard, and this one is in a lot of ways, and there actually may be a follow-up. I was telling somebody right before services, I thought that this one would kind of wrap up our series, and it will in a sense, but I think there's actually more that we could cover. I appreciate a lot of you all have given some really good feedback on these. You say that they've been helpful, they're encouraging, they're faith building. So if I have, I'm not going to promise one a month necessarily, because I don't know exactly how many more of these there are, but we'll definitely try to keep something going on a regular basis, evidence-based like this, surrounding science and how it relates to the Bible, and how real science does not contradict the Bible, but it harmonizes perfectly with the Bible. So tonight, though, we're going to look at Earth being our perfect planet. We've looked at several different areas of study of science. A lot of these, as I've told you before, they came from Brother Wayne Jackson's book, The Bible and Science, an excellent book. I would highly recommend that to you if you want to do a little more in-depth study from what we've talked about. There are other resources as well, and I may look into those, but this one, we're looking at Earth, and especially compared to our sister planets and our solar system. Brother Stone mentioned at the youth day that day that he was on an airplane at one time, and this was not all that long ago, and he said he began to talk to the man sitting next to him and found out he was a professor, and he was a professor at Auburn University. I said, okay, and what department are you in? Well, I'm in the biology department. Of course, you knew where that was going, in a secular university. And he says, well, what do you do? He says, well, I'm in the biology department, and I do evolutionary research. Oh. And so somehow or another, they began talking, and a lot of his research is centered around, is there life somewhere else in our solar system? Is there life on another planet? And the fellow said, this professor, he said, I think we eventually will find life on another planet. The reason, he said, is because really all the planets are pretty much just alike. Now, I could say, what do you expect from an Auburn professor? But I'm not going to say that. But Brother Stone pointed out that, you know what, sometimes teachers, professors can be wrong. And sometimes professors are wrong. And I don't care if that fellow teaches at Auburn, Alabama, Georgia, Notre Dame, wherever it might be, he's wrong. Because all the planets are not essentially the same. And that's going to be kind of the first part of what we're talking about tonight, a look at our planetary sisters. And I like kind of how he approached it. I think I may have mentioned this when we studied astronomy. And he says something, maybe for your next vacation, look at some of these planets and see if you might want to vacation there, even just a short vacation. And you conclude whether they're all really essentially just the same. You tell me. So that said, let's look at these, and I realized that using his for these planets, his images for these planets, I brought me a handout with me into the pulpit so I can try to help you make sure you fill in those blanks on the first part. The others should be in the PowerPoint. I say should be because right when I went to save it, my whole PowerPoint shut down, and Microsoft PowerPoint assures me it recovered my document. We'll see. So fingers crossed. We may have to wing it if not. But let's look at these planets. We're going to start, of course, with Mercury. But here's a look at, we've noticed this before. Again, we studied astronomy. Just to give you some context of what how the sun compares to our Earth. By the way, Brother Stone also pointed out at the youth day that day, the reason for starting NASA, the reason it really even began, A lot of times you ask that, and people, especially the generation or so before mine, I guess that'd be the baby boomer generation. Most baby boomers will tell you the reason NASA began was so we could beat the Russians to the moon, right? Show off our technology. And that, no doubt that was a big part of it. But it's to, and in fact, I was going back and listening to the recording, and I think when Brother Noby asked the question, I think it was Bob who answered it. He asked the audience, what's the other reason? And it's, as he says, the age-old question, are we alone in the universe? Is there life out there on another planet? And that, in large part, is what began NASA. But here you see the comparison of the planets to the sun, our sun, of our solar system. Even Jupiter. Jupiter dwarfs Earth in a major way, but even Jupiter is completely dwarfed by the sun. And you may recall from the lesson on astronomy that our sun is dwarfed very much so by several other stars that are out there, but that's not in the context of our study tonight. We're going to start talking about Mercury. Earth is about 93 million miles from the sun. Mercury is somewhere around 33 million miles from the sun. It's about a third of the distance from the sun that Earth is. Now, to fill in your blank there on the handout, if you want to go visit Mercury, you need to understand that it has 8 times the radiation intensity from the sun that the Earth does. So if you can imagine a hot summer day when you're out working and you think it's hot and you're sweating and you think, boy, I got to stay hydrated, well, you just try that on Mercury and you're going to have a tough time. 8 times the intensity of the sun as on Earth. There's no atmosphere on Mercury. There's no liquid water. There is extreme heat and extreme cold. Because of there are a number of reasons for that, but it's actually extreme heat and extreme cold. One rotation is 59 Earth days. A solar day, that's sun up, so the sun going down and then the sun coming up the next day, is 176 Earth days. And so when it's facing the sun, it's obviously it's a lot closer than the Earth, so it gets extremely hot. But when it's not facing the sun, it's facing deep space, and it gets extremely cold. In fact, to the tune of daytime temperatures get about 950 degrees Fahrenheit. Nighttime temperatures somewhere around negative 346 degrees Fahrenheit. So you better pack your warm clothes and your cool clothes. It won't matter because your blood's probably going to boil out there. Lead melts at 621 degrees Fahrenheit. That's 950 daytime temperatures. In fact, mercury boils at 673 degrees Fahrenheit. So if you took a thermometer out there, it's just going to blow it up. It's just going to boil and blow up the little glass encasing for the thermometer. That's what a trip to Mercury would be like. Again, the atmosphere, there really is no atmosphere. There's no oxygen, no water, the extreme heat, extreme cold. Mercury is not a place we want to go. What about Venus? Talk about Venus. When you look at Venus, you see some clouds. It looks like it's got some kind of an atmosphere, and it does. It actually does have an atmosphere. It's 2/3 the distance from the sun. It's about 66 million miles from the sun. It gets twice the energy from the sun as the Earth. So it's not 8 times as intense, but it is twice as intense. So again, you picture a hot summer day, double it. And that's Venus. It's when you get past this, it looks kind of neat in the picture, especially the upper inset there. It looks, like these beautiful swirling clouds. When you get past that, and you see there's a radar image here. Once you get past the clouds, you see it's not as appealing, is it? It's a pretty plain planet. It has constant 200 mile per hour winds. Now, Cliff and Cade and the other brother from Ironiton were here not too long ago. In fact, it was just a couple of Sunday nights ago, telling us about the relief for Hurricane Michael. I don't believe Hurricane Michael quite had 200 mile per hour winds, did it? They were up there in the upper 100s. But you picture nonstop 200-mile-an-hour winds, and somebody says, hey, got a place you can go live. Now, it's one big tornado, one big nonstop hurricane. You want to go there? Do you even want to go vacation there? You get the idea of what you're going to start to see a pattern. And you see the surface, Venus is not nearly as appealing. Its atmosphere is 15 times the Earth's atmosphere. 97% carbon dioxide, has sulfuric acid clouds. Not a very appealing place. Temperature, somewhere around 900 degrees. Again, no liquid water, no oxygen. That's Venus. Now, moving along in the solar system, here's Mars. Mars we know a lot about. It's about 150 million miles from the sun. Of course, we skipped Earth. We're going to come back to Earth later. But farther away from the sun than we are, the Earth, we know a lot about Mars because, just to put it bluntly, an insane amount of money has been spent by our government investigating, studying, researching Mars. And it's all really based upon, in many ways, this godless evolution that somehow or another we might find life that has evolved out there on Mars. And so your tax dollars hard at work, over and over again they go. I mean, to the point of they're probing rocks, they're investigating rocks, breaking them open, looking for anything they can find and trying to grasp at any straw they can grasp to say there's life on Mars, or even there has been life on Mars. The amount of research is just, it's really striking. Here's an image from Viking 1 orbiter. Of course, that's a picture from NASA. There is this, I want to make sure I got several notes here I want to mention. Mars has a maximum temperature of about negative 21 Fahrenheit. So you can picture, when I lived in Illinois, the first winter I spent up there, this country boy from Alabama, where, I was cold at 50, 40 degrees. The first winter I spent up there, it snowed on Christmas, which, I thought was really cool, and then it kept snowing, and then it did freezing rain, and then it snowed, and it did some more freezing rain and snowed again. And about New Year's, I was going crazy. And the temperature then set in for about a week and a half, I think. We never got above, I think it was negative 10. I thought that was just, I didn't even think I could manage to go outside without just dying, freezing to death. So you picture negative 21. That's about the max on Mars. The minimum is about negative 191 degrees Fahrenheit. Astronomers, they saw these polar caps on Mars. They could tell it has an atmosphere, and so they became very interested in Mars, and that's what started off some of this research. They also thought they saw canals at one time, and if you see canals, then somebody had to make those canals, so they began to think, there may be life on Mars. It's a very thin atmosphere. It's about 1/100th of the Earth's atmosphere. To get that same atmospheric pressure here on Earth, you would have to go 26 miles above sea level. That's the density or lack thereof of the atmosphere on Mars. It's also 100% carbon dioxide, like Venus. But with Venus was closer to the sun, so carbon dioxide, if you know, all the talk these days is about greenhouse gases. It's a greenhouse gas. So on Venus, the carbon dioxide atmosphere just holds in the heat, and so it's extremely hot. On Mars, it's far enough away from the sun, you don't get that greenhouse effect. There is something interesting here. There's this canyon, the Valles Marineris, and many people call it the Grand Canyon of Mars. It is 3,000 miles long with an average width of about 100 miles across. Pretty amazing. But again, scientists, NASA, our government has spent just ridiculous amounts of money researching, looking for life, even potential for life on Mars for about 40 years now. For about 40 years. They've been exploring this planet. There have been 8 or so orbiters circling the planet, taking pictures, sending them back to Earth. This has been going on for years. 4 rovers, at least 4 rovers, have been put on the surface of Mars. One of them was called Curiosity. It's, as Brother Noby Stone describes it, he said it's about like a four-wheeler, but it's a laboratory. It's a laboratory on wheels, and here you look at it. That's Curiosity right there. So, 6 wheels, but basically about the size of a four-wheeler. And that's just a laboratory on wheels to go all over the surface of Mars. They estimate that about 30 miles of the surface of Mars has been covered by various rovers and investigating the surface there. I believe this is the one that Brother Noby said that's the most expensive selfie ever taken. Curiosity grabbing a picture of itself with some of that equipment. But all these years and years of research, 17 years of rovers, 4 different ones, about 30 miles total travel, looking for life. They've bored through rocks, seeing what the rocks are made of, looking for evidence of water, evidence of methane. And methane is sometimes an indicator of life, but you can actually have methane that's not necessarily generated by life. They have found some fossilized evidence of water on the surface of Mars. Here's some more pictures from these. That's taken from one of the big craters on Mars. That's from a rover Opportunity. That's from the Victoria crater, some dunes that have been created. But they find these things like fossilized evidence of water. Here's a picture of these crater walls and they began to make a big deal about this, but really, long story short, it's a very extremely salty brine. It's located below the surface. And when the temperature reaches high enough on Mars, of course, it never gets above about negative 21 Fahrenheit, but this is a salty brine, so it doesn't take as warm a temperature to stay liquid. When the temperature gets warm enough, it'll ooze out of the surface. And so you see lines such as this where it has run down, and it just kind of oozes down, and it's, I think at the next picture I've got, I don't know if you can see that text, but it's hydrated salts, magnesium perchlorate, magnesium chlorate, sodium perchlorate. It's hardly what you could call, oh, look, we found water on Mars. When that was first discovered, some people began to tout that as if it was some kind of breakthrough discovery, but really it's not. In 40 years of Mars exploration, there's, of course, these are things we've already covered. Again, they have found, trace amounts of methane, but again, methane does not, if you have life, you will always have methane, but you don't always have life just because there's methane. It can be chemically produced. And that's a picture of a Martian sunset. But all these years, 40 years of Mars exploration, not a single blade of grass has been discovered, no earmark of life, not even a single-celled animal. No fossil evidence of life. It's just a barren planet. And so Mars, much like these other planets, it's not somewhere you want to go even for a short vacation. Moving on out, talk about Jupiter. Jupiter is what we call a gas giant. It's the largest planet, of course. You could fit, volume-wise, you could fit about 1,300 Earths into Jupiter. There's not really a surface on Jupiter. It's just a big ball of hydrogen gas. It's so massive, it has a tremendous gravitational pull. You take a 100-pound person, if they were on Jupiter, they would weigh about 260 pounds. The maximum temperature, as you see there, is about 54,000 degrees Fahrenheit. The minimum is about negative 171 degrees Fahrenheit. How on earth, well, that really doesn't work, does it, when you're talking about Jupiter? How does Jupiter manage 54,000 degrees Fahrenheit as its max temperature? It's interesting because Jupiter, it emits more energy than it receives from the sun. It's way on out there from the sun. Brother Stone was saying this, I had not realized this. Jupiter was almost a star, but it wasn't quite hot enough for the nuclear reaction to, for lack of a better term, to ignite. Jupiter rotates once every 10 hours. Our day is 24, so it's rotating more than twice the speed of Earth. That fast rotation and the size of Jupiter, its massive size, makes it, there's a technical term that he uses for this, but I call it a squished sphere because that's essentially what it is. It's rotating so fast and it's so massive that it begins to kind of squish the sphere as it rotates. It also creates these cloud bands that you will often see on Jupiter. And of course, the famous red spot, as you can see in this picture, that is just basically what would be essentially a massive hurricane there on the surface, not really a surface of Jupiter. It's gas, and it's a gas giant, so it really doesn't have a surface. But that red spot, that hurricane-like red spot, is so massive it would swallow Earth and Mars together. If that hurricane came to Earth, we're done. But that's Jupiter. It's so massive that that looks tiny on the surface of Jupiter. Moving on to Saturn. Saturn is 10 times further from the sun than the Earth is. Very similar to Jupiter, except it has the famous rings, tens of thousands of rings. I just forgot. I've told you I was going to go through the handout. See, Mars. Mars has a carbon dioxide atmosphere. Jupiter has no real surface. It's a huge ball of hydrogen gas, just to make sure you got those blanks filled in. Saturn, again, very similar to Jupiter, but it has the famous rings, tens of thousands of those rings. It's much like Jupiter, no solid surface, no liquid water, no oxygen. That's Saturn. Again, these gas giants, they don't really even have a surface. They're just essentially large, huge balls of gas. Here's one of the moons, Titan, about 62 moons, if I remember correctly, for Saturn. One of the moons, Titan, has an atmosphere, and it also has what appeared to be highlands with some type of drainage. There's a view of the atmosphere of Titan. They noticed that Titan has an atmosphere. So that always gets researchers' attention. And then they also found these, if you've ever been in an airplane, you've seen looking down on Earth, you see this. There are areas that are higher and all these rivers, creeks, and things like that are flowing, and they always flow somewhere. Eventually, sometimes they're flowing to lakes, but even the lakes eventually make their way to oceans. And so you have lakes and oceans and things that they're emptying into. And so they notice this, these what looks to be rivers, creeks, things that are draining into a basin of sorts. And so now they're really intrigued, right? Is this water? Is this what we've been looking for on one of the moons of Titan? One of the moons of Saturn. So they go out there and, looks can be deceiving, right? And boy, isn't that the case with Titan, because what they found out is the surface of Titan has a temperature around negative 290 degrees Fahrenheit. Its atmosphere is 95% nitrogen, 5% methane. These rivers and lakes, and it even rains on Titan, but not water, it's liquid methane and ethane. The rocks are just water ice. The dunes are this hydrocarbon type of sand. And so even the moon of Saturn doesn't work. You're not going to be able to eke out a living there. Moving on to Neptune. Neptune is another giant. It's actually not heated by the sun at all. It's so far out from the sun, it's not heated by the sun. It's actually heated by its radioactive core. It's covered with clouds. You can see that here in the picture. About 5,000 miles below the clouds is an ocean. And some people estimate it's around 6,000 miles deep. And it's an ocean of scalding hot ammonia. If you want to go to the beach, you might not want to plan for a trip to Neptune. Scalding hot ammonia is what makes up that ocean. And then, of course, there's Pluto. Do you include Pluto? Do you leave him out? One minute it seems like they're saying he's a planet. One minute it seems they're changing their mind. I read something, I don't know, it's not been that long ago, said they were going to say Pluto is a planet. I don't even know what the latest is, but I thought I'll throw it in here just to mention it. Pluto is mostly ice. It has this giant frozen ocean of nitrogen ice. Let me see the picture where that is. That heart-shaped portion right there. That's a giant frozen ocean of nitrogen. And so Pluto is very barren, mostly ice. and the temperature is at least negative 340 degrees Fahrenheit. As you would expect, very, very cold on the surface of Pluto. A lot of interesting pictures that NASA's been able to obtain of Pluto. But now, coming back to Earth, I want to go to Genesis 1, first of all. And I want to notice something. Of course, Genesis 1:2 on the screen there. The earth was formless, empty. Of course, the King James is without form and void. Darkness was over the surface of the deep or upon the face of the deep, and the Spirit of God moved upon the face of the waters, or hovering. Some translations have brooding over the face of the waters. But when you go to Genesis 1 and verse 6, God said, "Let there be a firmament in the midst of the waters, let it divide the waters from the waters." God made the firmament and divided the waters which were under the firmament from the waters which were above the firmament, and it was so. God called the firmament heaven, and the evening and the morning were the second day. And then you drop down to verse 11. God said, "Let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit after his kind, whose seed is in itself upon the earth," and it was so. You can drop down to verse 20. God said, "Let the waters bring forth abundantly the moving creature that hath life, and the fowl that may fly above the earth in the open firmament of heaven." 24. God said, "Let the earth bring forth the living creature after his kind, cattle and creeping thing and beasts of the earth after his kind," and it was so. And 26. And God said, "Let us make man in our image, after our likeness. And let them have dominion over the fish of the sea, and over the fowl of the air, and over the cattle, and over all the earth, and over every creeping thing that creepeth upon the earth." That's something unique about Earth. It's not seen on any other planet. No other planet has continents. No other planet has temperate oceans. No other planet has water vapor clouds. Not a single microbe has been found anywhere else. Does that seem just really, really convenient? Really, really coincidental? Or is it evidence that there's something more than just mere chance going on here? If you're not convinced, let's keep going. This may be where I went through, I read these verses. Here we go. And you may see this on the bottom of the handout there. In the story, Goldilocks and the Three Bears, Goldilocks, she came to Papa's bed, it was too big. The baby's bed was too small, and the other one, had to have it just right. Goldilocks wanted it to be just right. Well, when it comes to life, you've got to have things just right. That's why when you go to Mercury, Venus, Mars, Jupiter, Saturn, Pluto, all these different planets, you don't see life. The conditions aren't there. Earth is the perfect planet for life. What do you need for life? You need some things to be just right. For one thing, you need the right ingredients to have life. You see, for life, a planet has to have liquid water. Not only that, you got to have these building blocks for life, like carbon, oxygen, hydrogen, nitrogen. There are certain things that you've got to have, and if you don't have liquid water, you're not going to have life. If you don't have some of these other building blocks, you're not going to have life, so you got to have the right ingredients. Guess where we find those? There's one place in the solar system where you find all that. It's a place called Earth. Not only that, you got to have the right crust. You got to have the right crust. What about Earth makes it just right? Well, the gas giants, they don't have a solid enough surface. They really don't have a surface at all. It's gas. Earth possesses this suitable distribution of elements that maintains a hot metallic core and a rocky mantle. The right crust. You find that on Earth. What about the right temperature? You also got to have the right temperature. You see, if the Earth is too hot, then you don't have liquid water because all you have is gas. If it's too cold, you don't have liquid water because all you have is ice. That's what you see in Pluto. It's just solid ice, basically. So you got to have the right temperature if you're going to have this perfect planet. This is where didn't save right. You got to have a right moon, number 4. This is number 4, right? Yeah, you got to have the right moon. The moon that the Earth has, and I thought about this after I put it, the Earth's large moon, when we say large relative to the size of the Earth, compared to Jupiter or a moon of Jupiter or Saturn or some of these other planets, it's not that large, but compared to the Earth size, it's a pretty large-sized moon. It minimizes the planetary tilt. It ensures climate stability. Not only that, Earth's perfect tilt gives us seasons that are not too extreme. If the Earth doesn't have that tilt and it faces the sun, then when it faces the sun, it is like some of these other planets. It's hot. And then when it turns and finishes that rotation, the other side is facing out into deep space, it is super, super cold. And you have temperature extremes. Now, some of that's helped by oceans and things like that, but a lot of this is from having the right moon. Let me read something to you. This comes from a website called Live Science. I don't know, maybe it's supposed to be pronounced Live Science. I just prefer to call it laughable science as what they're saying. But let me read you the quote, if I can read it with a straight face. When a Mars-sized object collided with Earth 4.5 billion years ago, it knocked off a chunk that would become the moon. It also tilted Earth sideways a bit, so that our planet now orbits the sun on a slant. Wow, isn't that interesting? I mean, a Mars-sized object collides with Earth. It knocks off a spherical piece. It flies out and just whoop right there, right perfect orbit to control tides and help to have climate stability. Isn't that convenient? I mean, what are the chances, right? I got one word for that, LOL. and I don't mean lots of love. Those of you that remember a few years ago, one of our gospel meeting speakers said he figured out LOL means lots of love. Laughing out loud. It would be hilarious if it were not so serious. I cannot believe that someone would put that on a website and call that science. That something hits Earth and it just happens to knock off this perfect object that goes just a perfect distance from the Earth, that it helps make Earth perfect for life. And oh, by the way, it knocked Earth just at a little bit of a tilt so that now we don't have these just wicked extreme temperatures. We have temperate seasons. I mean, isn't that convenient? Isn't that coincidental? Give me a break. I am not that stupid. And I'm not buying it. God did that. It is just amazing that someone will put that out there and expect folks just to buy it. And too many folks do buy it, sadly, without ever even thinking about how utterly ridiculous it is. But you got to have the right moon. Not only that, you got to have the right star. You got to have the right star. Think about this. Our sun provides energy for life, and thankfully we have a rather stable star around which our Earth orbits. Because if you don't have a very stable star, an unstable sun, it could just vaporize the Earth. Or it could freeze it. What if it just goes out? One website I read, or I think it was on a website, they used the illustration of, imagine trying to cook a pot roast in an oven that you don't know what it's going to do. It may just on its own go up to like 1,000 degrees. Or it might just stop in the middle of cooking and just quit, and everything just goes cold. Our sun is stable. We know what it's going to do. In fact, Brother Stone pointed out in his presentation, a 10% brighter sun, just 10%, would evaporate our oceans. That's pretty amazing. And isn't that coincidental? That our sun is just right, and that happens to be the sun around which our planet is orbiting? It's not coincidental. It's providential. But you got to have the right star. You also got to have the right core. Earth's solid inner core, its liquid outer core, they create electrical currents that help to drive the magnetic field. What does the magnetic field have to do with anything? It protects us from charged particles of solar wind. Solar wind would otherwise strip our ozone layer right away from the Earth. And so what the Earth's core is doing is help protect us from sun radiation. The magnetic pull can help hold the ozone there. There are other things as well, but that's kind of the big thing. And it helps keep our ozone to protect us from the radiation of the sun. And then, of course, you got to have the right neighbors. What do I mean by that? Well, just one example here in particular, Jupiter. We mentioned Jupiter is the largest planet, this massive gas giant, as it's often called. But it has such gravity that it helps protect Earth from some meteors. Now, there's some difference among scientists, but some scientists estimate as much as 10,000 times more asteroid and comet strikes were it not for the planet Jupiter. Can you imagine? In fact, Brother Stone gave an illustration in his presentation that if you didn't have the atmosphere of Earth, and if you didn't have some of these larger planets drawing away those comets and asteroids and things like that, that even a comet or some type of object the size of 3 grains of rice put together, by the time it got to the Earth's surface from outer space, would be traveling as if it would be very similar in size to a bullet fired from a .30-06. Hey, can you imagine that? And without our atmosphere and without some of these planetary neighbors, you would have basically a constant drizzle on Earth of that. All these things come together, and they make Earth, just like Goldilocks would like it, just right. Our perfect planet Earth. There is not another place in the galaxy, in the solar system, in the universe that is perfect for life except right here on Earth. Folks, there is no way, no how that is chance. That is the providence of Almighty God. And it's no wonder that God inspired the psalmist to say, "The heavens declare the glory of God," Psalm 19:1, "and the firmament showeth his handiwork." The wise man said after he'd lived his life, he had tried so many things to find happiness, to find meaning in life, to find purpose in his life, and he finally realizes near the end of his life in Ecclesiastes 12:13 and 14, and he says, "Let us hear the conclusion of the whole matter. Fear God and keep his commandments, for this is the whole of man. For God shall bring every work into judgment with every secret thing, whether it be good or whether it be evil." So many times we realize that we are flawed, sinful creatures, and sometimes we don't want to think about that. We don't want to have to think about the consequences of sin, and so sometimes people just begin to push God out of their minds, and they try to push God out of their lives, but facts are stubborn things. They don't just go away. And the fact is, one day you and I were going to stand before our Creator. And we don't have to stand before Him and suffer eternal death and eternal punishment in hell for our sins, because He sent His Son to die on the cross for us. But make no mistake, the evidence is around us that screams God is. And knowing that God is, I'm going to stand before Him one day in judgment, and I'm going to give an account. And you're going to stand before Him one day, and you're going to give an account. Knowing that, would it not behoove us to give thought to these things? To fear God, to keep His commandments, and to realize that nothing else in this life matters. If we can help you tonight in fearing God and keeping His commandments, that's what we stand ready, willing, and able to help you do as we stand and sing.